Welcome back to Maths with Mrs. J. It's now time for us to use our knowledge of our inverse trig functions to put together some way of giving a general solution if we have a trig equation. These look complicated and they are a little bit fiddly, so let me explain them to you so that they make sense. I'm actually going to start by explaining the tan one first because that's the easiest one to understand. Just bear in mind that in these general formulas, n is always an integer. So either +1, +2, +3, or 0, -1, -2, etc. Now, if tan of theta is b, then our general solution for theta will be pi times an integer plus our inverse tan. Let's think about this in the two different categories. If our inverse tan is a negative number, we know that inverse tan is going to be from -pi/2 up to 0 for our answer of our theta. So if we have a negative tan value, we're going to be down in this quadrant here and we're going to be talking about a negative angle. So negative pi/4 or negative pi/3 or whatever the case may be. Now, if tan is negative, we know that you must be in your fourth quadrant, or you could equivalently be in your second quadrant. This value would be the same as having your theta next to your axis here. Tan actually has a period of pi. So the negatives repeat themselves every pi. So you can add pi, you can add pi, you can add pi, you can add pi, and you're going to get to a place on the unit circle where it has that negative tan value, that same negative tan value, or you could subtract pi and you're still going to end up with the same thing. If tan were positive, then you're going to have your theta in your first quadrant. And again, to get to any other places on our unit circle where we have the same tan value, we're just going to add pi or 2 pi or 3 pi or 4 pi because tan has a period of pi. All right, we're either going to be in the first or the third quadrant if tan is positive. So the value you get from either a calculator or preferably from your exact values would be between 0 and pi/2 if tan is positive. And then we can just add however many pi's we like to take us either back to this spot. So if we're adding 2 pi, 4 pi, 6 pi, or taking away 2 pi, 4 pi, 6 pi, if we're adding an odd number of pi's, we're going to end up in this quadrant here. So that's why the tangent one works. Tan has a period of pi. So whatever our inverse tan is, we're just going to add an integer times that pi. Let's now have a look at the cos because that's the next easiest to understand. Okay, again, let's think about if it's positive or negative. If cos is positive, then we're actually talking about a value between 0 and pi/2. And bear in mind, if cos is positive, we actually have this scenario where we could either have our plus pi or our plus theta or our minus theta, don't we? Remember that your x value is the same in your first and fourth quadrant. So how are we going to get this first and fourth quadrant situation happening? Well, the cos inverse of b will tell you this value here, this theta value. And then if you're doing 2 pi times an integer plus that, that's going to keep getting you back to the first quadrant. So 2 pi or 4 pi or 6 pi or whatever. 2 pi minus that value will give you all of these ones down in the fourth quadrant. If cos were negative, we'd be talking about your third or fourth quadrant. And again, same sort of thing. To get to these points, you'd be adding 2 pi or 4 pi or 6 pi or taking away 2 pi, 4 pi, 6 pi. To get these points, you'd be doing your 2 pi minus this value and then adding 2 pi, 4 pi, 6 pi, whatever, okay? So that works for both positive and negative. Now the sine one is a little bit more fiddly. Let's have a bit of a look at it. Let's just see what this actually evaluates to for different values of n, just so that we can see what on earth we're dealing with. So if n is 0, then obviously our theta, we're just going to get our -1 to the 0, which is 1, we're just going to get our value, right? So whether that be, obviously our negative sign is going to be in from negative pi on 2 up to pi on 2. So if it's negative, it will be in this quadrant. If it's positive, it'll be in this quadrant. And that's the value that we'd get either from our exact values or from our calculator. If n is 1, let's see what happens there. So our theta is going to be pi times 1 plus -1 times 1. So that's plus -1 times inverse sine. Now, what's that actually doing? Pi minus inverse sine. Well, what you're actually doing, imagine that your theta is here. So let's just imagine for a minute that we're thinking about a positive sign. We're talking about our first or our second quadrants, aren't we? So to get this one, we do pi minus theta, wouldn't we? That is your equivalent of your pi minus theta. If n is 2, we're going to get our theta is going to be 2 pi plus -1 raised to the 2 is +1, our inverse sine. So that's going to get us right back to here. N is 3 will give us our 3 pi minus theta. And that's why that rule, as complicated as it looks, that's why it actually works. It gives you your theta or your pi minus theta. If sine is negative, the same sort of thing works. What will happen is your negative value will be here and you'll be doing negative pi and in essence minus your negative theta. So you're still going to be getting these values and these values if sine is negative. Bear in mind, sine is negative in your third and fourth quadrants. So yes, I agree, these are a little bit fiddly to understand and to work with. It's not that common that you're actually asked for a completely general solution. It's more likely that you're asked to just find a solution, say if theta is between 0 and 4 pi, for example, in which case you can actually just think about how you would label these points on the unit circle if you like. But they are important to know as well. Okay, let's move on and actually do some examples. We're not going to do many examples because it is a little bit fiddly. Okay. Alrighty, so here we have 3 examples. I'm only going to do 3. Notice that all of these are examples, you probably can't tell from that one, but all of these are ones that you should know exact values for. Using your calculator in radians and doing inverse tan or inverse sine or inverse cos is a last resort. It will give you an approximation. We don't particularly love approximations unless it is a real life situation, in which case it's perfectly appropriate to have an approximation. So let's see how we get on with these questions here. First one, tan of theta is 1. If tan of theta is 1, then inverse tan of theta, or theta will be inverse tan of 1. 1 is a positive number. So we're looking for a value of theta between 0 and pi on 2. Remember, inverse tan is going to be between negative pi on 2 up to pi on 2. Because tan is positive, we must be in the first quadrant. Thinking about our table of values and using that in reverse, we should hopefully know that theta is pi on 4. So our general solution is just going to be our pi times n plus our pi on 4. That's all we need to do. Nothing more complicated than that. It's not going to be, that's our inverse tan of our 1 there, all done. Okay, and we should say that n has to be an integer, obviously. You can't have add half pi to that and expect it to work. All right, cos is negative a half. Let's just think back to our general rule for our cos. And this one was a little bit fiddly, but that's okay. So our general solution was that theta is 2 pi times n plus or minus your inverse cos. So in this case, it's going to be inverse cos of negative a half. Excuse me. And of course, n is an integer. Inverse cos of negative a half. Now we've got to think for a minute. Inverse cos has to be between 0 and pi. If cos is negative, we must be therefore between pi on 2 and pi. All right, so we need to be between pi on 2 and pi. In your first quadrant, to have a cos of a half would be pi on 3, wouldn't it? Just thinking back, pi on 3 has an x value of a half. So the equivalent value that we're looking for is going to be pi minus pi on 3, which of course is 2 pi on 3. So this here, so our general solution will be theta equals 2 pi n plus or minus your 2 pi on 3, where of course n is an integer. Okay, we needed our 2 pi on 3 because our cos was negative, and cos is going to be between 0 and pi. Sine and tan are between negative pi on 2 and pi on 2. This one here, we're going to have to fiddle with it a little bit first before we can work with it. So what we're going to get here is that sine of 3 theta is negative root 3 on 2. Just work with it as a 3 theta for now. So our 3 theta using our general rule. So it's going to be pi n plus our negative 1 to the n inverse sine of this value. Keep it as a 3 theta for now, and we can divide everything by 3 once we're done. Inverse sine of a negative. So we're going to be between negative pi on 2 and 0. To have a sine of 3 pi on 2 would be pi on 3. So this must be negative pi on 3. So we're going to get 3 theta is pi n plus negative 1 to the n times negative pi on 3. And now all we need to do, well, we can change this to that, and we can just divide everything through by 3. So we're going to get pi on 3 times n minus negative 1 to the n times pi on 9. And yes, that is complex, but that's about as hard as they're going to get. The only other sorts of equations you might meet, and you need to be aware of it, if you were asked to solve something like sine of theta is 4, you should know that sine of theta can never be 4. Sine of theta is always going to be between negative 1 and positive 1. So you've got to bear all of those sorts of bits of basic information about our unit circle and our trig functions, as well as our new information about our inverse trig functions. You've got to bear that in mind. It's a lot to think about. Do quite a bit of practice because it is a little bit tricky there, and then you should be right. Our next video, we are going to start differentiating our inverse trig functions.